the unit 1 in power system transients, and briefly we are going to discuss the definition and classifications of power system transients. Definition: an electrical transient is a temporary exchange of voltage or current in an electrical circuit when a fault occurs on a system or a switch opens or closes. That is, it is simply a sudden change in voltage or current when a fault occurs. And we know that the main purpose of power system is to transport and distribute the electrical energy generated in the power plants to the consumers in a safe and reliable way. But transient reduces the efficiency and it also disturbs the energy transportation, so that transient has to be eliminated. We can't eliminate the transient at 100%, but we can control it to certain limit. By definition, a transient is a aperiodic function of time and has a short duration. And also, a transient phenomenon may be of voltage or current. It may be due to either voltage or due to current. The voltage surges are due to sudden change in voltage at a point in power system, and its velocity depends on the medium in which the surge is traveling. Such voltage surges always associated with current surges when it travels, and these current surges are due to charging and discharging capacitive currents that are introduced by the change in voltage across the shunt capacitance of the transmission system. And classification: there are several classifications based on certain reasons. First one is based on their origin, and next is based on the mode of generation, and based on frequency range, and depends on its nature. Finally, depending on control on the transients. We'll go into the brief discussion. First, based upon their origin. There are two types of transients generated based on their origin. One is of atmospheric origin and the other one is of switching origin. That is, for atmospheric origin, the best example is lightning. It is a natural phenomena, we know, right? So due to lightning, if the transient happens, then it is of atmospheric origin. All other transients, that is due to switching operations, load rejections and faults, comes under switching origin. The next classification is based on their mode of generation. There are two classifications in this. One is electromagnetic transients and the other one is electromechanical transients. If the transient creates due to the interaction between the electrical fields of capacitance and magnetic fields of inductance in the power system, then it comes under electromagnetic transients. These electromagnetic phenomena may appear as traveling waves on transmission lines, cables, bus sections, and oscillations between inductance and capacitance. Next one is electromechanical transient. These transients are generated due to the interaction between the electrical energy stored in the system and the mechanical energy stored in inertia of the rotating machines. So, if the transient due to interaction between electrical and magnetic field, then it is called electromagnetic transients, and if the transient is due to interaction between electrical energy stored and mechanical energy stored, then it is called electromechanical transients. Next, based on the frequency range, that is, while creating or while transient is generated, it has certain frequency range. So depends on that frequency ranges, we are classifying the transients as low frequency oscillations, slow transients and fast transients. The range of frequencies for low frequencies are 0.1 Hz to 3 kHz, and it is mainly due to temporary overvoltage. And the range for slow transient is 50 to 650 Hz to 20 kHz due to switching over voltage. These slow transients are due to switching over voltage. And fast transient, the range of these fast transients are 10 kHz to 3 MHz, and these fast transients are mainly due to restriking over voltages and GIS. Next, the general frequency ranges created because of these reasons are: one is lightning surges, the frequency range is 10 kHz to 3 MHz. Whereas the restrikes in circuit breaker, the frequency range is 10 kHz to 1 MHz, and fault clearing, the frequency range is 50 Hz to 3 kHz. For fault initiation, the frequency range is 50 Hz to 20 kHz, and while the transient is created using fault energization, the frequency range is 50 Hz to 3 kHz. If the transient is created due to load rejection, then it is due to load rejection, so the transient lasts for 0.1 Hz to 3 kHz. And if the transient is created due to transformer energization, then it is due to 0.1 Hz to 3 kHz. Finally, the transients due to ferro resonance lasts for 1 Hz to 1 kHz. And depending on its nature, the transients are classified into three further classifications. One is low frequency transient, and the other one is medium frequency impulsive transient, and the last one is high frequency types. Under low frequency transients, we have further two classifications. One is impulsive transient and the other one is oscillatory transient. The impulsive transient rises at 0.1 milliseconds and it lasts for more than 1 milliseconds, and oscillatory frequency transient contains frequency components which is up to 5 kHz. And the next classification is medium frequency impulsive transients. It lasts between 50 nanoseconds to 1 milliseconds, and its oscillatory lasts between, that is the frequency range lasts between 5 and 500 kHz. They are less than the low frequency types but have much higher amplitude. Comparing to low frequency transients, they are of low frequency but it has a higher amplitude and it causes much damage than the low frequency transients. And finally, we have high frequency types. Here the frequency ranges between 0.1 megahertz and 5 megahertz. The frequency range is much higher than the other two, and the duration is between 50 nanoseconds. Thank you.